All right, let's talk about one of the biggest buzzwords flying around right now, the AI algorithm. What on earth is it really? And more importantly, how does it actually work? Okay, let's get into it.
It really can feel like magic sometimes, can't it? You type a question into a box and a perfect answer just appears. Or you look at a product online once and suddenly ads for it are following you everywhere. How does it know? Is there some kind of digital wizardry going on?
I absolutely love this quote from our source material because it just perfectly nails that feeling. You almost picture this little person inside the machine, just frantically pulling levers to make everything work. It's a great image, but the reality, well, it's a little less frantic and a lot more methodical. And there you have it. If you remember one thing, make it this. The best way to think about an AI algorithm is that it's a recipe, not a magic spell. It's just a very, very detailed set of instructions for a computer. This one idea is going to be our guide for everything else. So let's dig into this whole recipe idea. First things first, we need to get our definitions straight. What is this recipe actually for? The key word here, the one that changes everything, is learning. See, a normal recipe for a cake, you follow the steps, you get the same cake every single time. But an AI algorithm is designed to get better. It looks at examples, it tweaks its own steps, and it refines what it's doing based on new information. And this is just a brilliant reminder that the process is not perfect. An algorithm is just following the patterns it learned. So if a fluffy pillow happens to share enough features with the thousands of cat pictures it's already seen, well, it's going to yell cat with 100% confidence. It's powerful, for sure, but it's not foolproof. Okay, now let's clear up a really common point of confusion. You'll hear people use the words algorithm and model like they're the same thing. They're absolutely not, and the difference is super important. So here's the deal. The algorithm is the cooking process. It's the recipe itself, the techniques, the instructions on how to mix the ingredients. The model, that's the finished meal. It's the actual cake you baked. You can use the exact same algorithm, the same recipe, with different data or ingredients to create totally different models or meals. So if the algorithm is the recipe, how in the world does it actually learn how to cook? What does that whole process even look like? It basically breaks down into two big phases. First up, you've got training. Think of this like the algorithm is studying for a huge exam. It's just cramming, going over tons and tons of data, making guesses, checking its answers, and adjusting itself over and over to get better. Then comes inference. That's the test. That's when you take that trained model and you let it loose on brand new data to see what it can do. Now, it turns out there are a few different styles of learning. The one you see most often is called supervised learning. This is where you basically give the algorithm a giant cheat sheet. You feed it a ton of data where all the answers are already labeled, like this is spam, this is not spam, until it starts to pick up on the patterns all by itself. Then you have the total opposite, unsupervised learning. This time, there are no labels, no cheat sheet. You just drop a huge, messy pile of data in front of the algorithm and say, go find something interesting. And it's amazing at finding hidden connections you never would have seen, like automatically sorting your customers into different groups based on their buying habits. And finally, there's reinforcement learning. The best way to think about this one is like you're training a puppy. The algorithm tries something. If it's a good move, it gets a treat, a reward. If it's a bad move, it gets nothing. And after doing this millions or even billions of times, it eventually learns the sequence of actions that gets the most rewards. This is how AI learns to play and win really complex games. So this isn't meant to be some kind of best of list. It's more like a quick map of the different kinds of recipes out there. You've got your simple, low-cost stuff like linear regression. Think of it as a really basic, reliable recipe for finding simple trends. Then you have things like random forests in the middle. They're more complex, kind of like combining a bunch of simple recipes to make one really solid dish. And then way at the high end, you've got neural networks. These are the super complex, gourmet recipes that can handle really tricky ingredients like images and language. But man, they need a ton of data and a lot of time in the oven to get right. Okay, so we've covered how they learn in theory. But using them in the real world, well, that's where things get really tricky. It's not as simple as just grabbing the fanciest recipe off the shelf and expecting it to work. I mean, even the absolute best teams run into these classic problems. You've got overfitting. That's where your model basically memorizes the test answers but can't handle new questions. There's data leakage, where it accidentally cheats by seeing information it's not supposed to. Then you have bias, a huge one, where bad historical data teaches the model to make unfair or wrong decisions. And concept drift, that's when the real world changes and the patterns your model learned just aren't true anymore. And this points to a really subtle but incredibly dangerous problem called automation bias. Because the AI sounds so confident, we just tend to believe it. We stop checking its work, we stop thinking for ourselves, and in high-stakes areas like medicine or finance, that can be a massive risk. And this is exactly why the goal has shifted. We're not just trying to build accurate AI anymore. The goal now is to build trustworthy AI. We need systems that are not just right, but that are also provably safe, that are transparent, that are reliable. The big questions we have to ask are, how does this thing fail, and can we explain why it's doing what it's doing? So after all that, all the technical details, why should you actually care? Well, because whether you realize it or not, these algorithms are already shaping our world in thousands of little ways every single day.
So if you walk away remembering just 3 things, make it these. 1. The algorithm is the recipe, the model is the finished meal. 2. The quality of your ingredients, your data, is way more important than the complexity of your recipe. Garbage in, garbage out. And 3. A truly great AI isn't just accurate. It's reliable, it's constantly being watched, and it's rigorously checked for bias.
And that really brings us to the final and maybe the most important question of all. We've got these unbelievably powerful new tools, but any tool is only as good as the problem you point it at. So as we build these things, we have to keep asking ourselves, are we actually solving the right problems? And are we doing it in a way that doesn't create even bigger ones down the line? That right there is the real challenge. Thanks for tuning in.